Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay. So this is the new problem in front of us. The problem says that you have been given an array of integers. Return the kth largest element. So you have to assume that the length of the array is n, and inside this unshuffled or like shuffled array of length n, you will be given a value k also, and you have to return the kth largest element. For example, if in this case the value of k is 2 and this is the given array, then the answer will be 9, because you can see the first largest or the largest element is 16. The kth largest, that is the second largest element, is 9. The only catch is n can be as big as 10 raised to the power 6, k can be as big as 10 raised to the power 2, right? So how can we solve it? So one way that you can think of is, how about you apply, let's say, bubble sort or selection sort on the whole array and sort the array, and then return kth element from last. This can be one approach that might come to your mind. But the problem with this approach is that if you will sort the array, let's say using selection sort or insertion sort or these lesser efficient sorting algorithms, then in the worst case it can go till n square. And n square is going to be of the order of 10 raised to the power 12, which is not going to be completed in 1 second. So we'll get time limit exceeded, right? You might think that you can use some internal sorting algorithms, or there are more efficient sorting algorithms that works around n log n. We will talk about them later, right? But there are other caveats with that, right? Let's say if k is very small, then also those, like let's say if k is of order of 10, let's say k is of. So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our System Design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video. Order of 10 instead of 10 is to k is of order of 10, and you use the efficient sorting algorithms like merge sort, quick sort, or something like this. We will discuss about them in some other part. Then also you will be like sorting the whole array. N log n will be around what? 10 raised to the power 6 into log of 10 raised to the power 6 is around 20. So 2 into 10 raised to the power 7, right? You will still do these many operations approximately, right? But we can do something more efficient. We can do something more efficient. Doesn't matter what the value of k around is. So actually these kind of problems where you have to return the kth largest, kth smallest is also called as kth order statistics. Kth order statistic problem, right? Also called as the kth order statistic problem, in which you have to return some kth order element. These kind of problems can be solved in different ways. Like there are different data structures that can efficiently solve, right? The most efficient algorithm technically to solve this question can solve this problem in order of n time, right? We're not going to discuss about that algorithm yet because this I would say part is going to be focusing on some other algorithm, right? That is going to be definitely better than sorting the whole array. But this order of n solution is technically the quick select algorithm, right? We'll discuss that in other parts, right? But currently in this part, I'm going to tell you a solution that can work in order of nk. This solution can work in order of nk. How can you do that? So what you can do, you need to find the kth element from the last, right? When you sort the array, you are getting the kth element from last. And if you remember bubble sort in one iteration pushes the biggest element of the unsorted region to the last. So just think about it. If you apply bubble sort on this array once, then it will push 16 at the last, right? So let's see, 4, 1, 16, 3, 2, 9. 4, 1, 16, 3, 2, 9. So let's see. Is 4 greater than 1? Yes, it is. Swap. Is 4 greater than 16? No. Is 16 greater than 3? Yes. Swap. Is 16 greater than 2? Yes. Swap. Is 16 greater than 9? Yes. Swap. And you can see in one iteration, you have the biggest element at the last. Then you again do, is 1 greater than 4? No. Is 4 greater than 3? Yes. You swap. Is 4 greater than 2? Yes. You swap. Is 4 greater than 9? No. And now you can see in the second iteration, you have the second largest element at the last. And that's it. We can stop the algorithm here. So what you can do is, we can do k iterations of bubble sort, right? When you have to completely sort the array, then you do these iterations n minus 1 times, right? But what if I do this only k times? Then the complexity will be order of n into k, right? Because in every iteration, you do n comparisons and in the worst case n swaps also. So if you just do it k times, then you will be doing n comparisons k times. So the time complexity will be order of nk. And if n is of the order of 10 raised to the power 6 and k is of order of 10 raised to the power 2, then this thing will get submitted because the overall complexity will be 10 raised to the power 8. So you can use bubble sort and do the iterations of bubble sort k times. That is of pushing the biggest. And when I say iteration of bubble sort, then I mean pushing the biggest element of unsorted region at the last. That's it. So you can solve this question in order of n into k, right? You can even use There are efficient algorithms also, like even more efficient than this. Like as I said, the most efficient one is quick select. We can discuss them in further upcoming set of parts. But this was the solution using bubble sort for this corresponding problem.